All right, so now we're going to learn about something called slope fields. All right, we're studying differential equations, and differential equations can be tricky to solve. I mean, we haven't learned any techniques yet to solve differential equations, unless it's just a differential equation involving x, and then we can do an antiderivative. But let's take, for example, this differential equation dy dx equals y. Now, we already said that in the previous lecture that one solution is just y equals e to the x, right? In fact, we could have y equals any constant times e to the x, and it would give us, it would satisfy this differential equation. So what we're going to do is, if we look at this equation, what it's telling us is that the slope of the function at any point is equal to its y coordinate. Okay, so if we have a solution that passes through, say, 0, 0.5, then the slope at that point is 0.5. If the solution goes through any point where y equals 1, then the slope is 1. All right? And so that can help us visualize the solutions to a differential equation. And the way we can do that is create a slope field just by essentially taking the Cartesian coordinate plane and plotting the slope at various points, right? So essentially we have a grid of x and y values, and we can calculate the slope for every x and y value on the grid. Now we're going to select discrete values, right? And so so this is an example of a slope field, right? All we've done is take the value. Now they've broken it down. They say it goes from 2 to -2, so they've broken it down pretty far. But essentially all we do is go to a point and plot its slope by drawing a little line segment that has the same slope as the function at that point. Okay? And by doing that, we kind of see a little bit of a ghost of the solution lurking in that slope field. So, and if we have a particular value that we know that the function satisfies, then those slopes, those little line segments that indicate the slope, are like signposts that direct us to the next value. So, for example, we'll do some examples here, but if we have this, let's say we had this point here, 0, this is 1.5, so the slope is 1.5, so that slope is pointing us to the next point. So if we wanted to find the point at 1, right, we could come up here and find the next point is somewhere then up here, right? That's where that slope, where that line segment is pointing us to, some point up here. Okay. All right. So let's look at some examples. Examples are always easier to understand, I think, than just words. So, all right, let's take a look at these two differential equations, and we're asked to just sketch the slope fields for these differential equations. All right, so the first one is dy dx is equal to x minus y. All right, so if we know a point, we can take the difference, x minus y, and find the slope. So if you look at any point along, if x is equal to y, right? If any place where x is equal to y, the slope is 0. So we can draw a little line segment anywhere along here where x is equal to y, and the slope is 0. Okay. So now what if they're 1 apart? Okay, let's say that x is 1 greater than y, right? So here's one of those points, 1, 0, right? So in all of those cases where x is just 1 greater than y, the slope is 1. So we can draw a line segment with a slope of 1 anywhere along here. All right, so I'm just going to draw in all of those points that have a slope of 1. Okay, and then we can keep going. We can also look what if y is 1 greater than x, right? Then the slope is -1. And -1 slopes are pretty easy. So let's see. So y is 1 greater than x. So let's take this point, right? That's an easy one. So that has a slope of -1. And really all along here, it has a slope of -1. Okay. And so so you just kind of keep going and then until you've covered all of the points. So let's just take one more example where let's say x is 2 more than y. So here's 2 comma 0. So the slope is 2. Now sometimes it's hard to just figure out, okay, what does the slope of 2 look like? Well, what I usually do is I look at the next column over, look at the next grid over, and I'm aiming, like if I'm here, right? Actually, let's make it a little bit more. I'm essentially aiming for 2 up, right? So I'm kind of aiming toward this point right here. I'll kind of draw a dotted line. I'm kind of aiming in that direction. That's 1 up and 2 up and 1 over, right? So it gives me a slope of 2. So I just kind of use the grid to help me aim to get an idea of what a slope of 2 looks like. So like if you need a slope of 3, just aim your line for 3 up and 1 over. Okay, so it doesn't have to be perfect. I mean, it's you know, if you're just asked to sketch, we don't have to get too crazy. And so anyway, all of these have a slope of 2. Okay, all along that diagonal. All right, so these things can get a little bit tedious to draw. Okay, so I'm not really into drawing slope fields by hand. But they are very useful because you can see now, you know, kind of what the general solutions might look like. So if I'm going to change pen colors here. So if I happen to know that the solution passes through, say, let me just I'll pick a point here. Let's say it passes through that. Then essentially this slope is telling me, okay, my next point is probably here, right? And then that's pointing me up here. So I think my solution is kind of going like this. Okay, if I want to go the other way, so I'm coming over here, this slope, remember the slope was 0 here, it's pointing me over here, and then that's pointing me up here. So my solution probably looks something like this for that particular initial condition. Now, that's pretty messy, but you kind of get the idea. It kind of gives you an idea. If you know, you have an initial condition, what does the function look like? So if I had an initial condition down here, then my solution probably looks something like that. So it's kind of messy. It's a sketch, right? So, all right, let's take a look at this other one. All right, so now we have the dy dx is equal to -x over y. So the first thing I'm going to do is okay, where are the slopes equal to 0? So the slopes are 0 anytime x is 0, right? So all along the y-axis, those slopes are 0. Now I could also look at, you know, whenever y is 0, essentially it's a vertical line. So I can also draw some vertical slopes along the y-axis here. So actually, I should probably erase this one because when both x and y are 0, it's an indeterminate case. So we're not gonna do that one. But we can then look at, okay, what if x equals y, right? Then the slope is a -1. So we're looking at slopes along here that are -1 where x equals y. And then we can also look at when x is -y or y is -x, and we're going to get slopes of +1 all along here. Okay. And then from there, you know, there's only a few points left, and you can sketch the rest of those in. And there you go. I just sort of sketched those in. And you might actually recognize this differential equation from when we were doing implicit differentiation. This is actually the differential equation that corresponds to a circle, right? So any circle will give you this for the derivative of, well, if you try to take the derivative of y with respect to x for anything that where you have x squared plus y squared equals r squared, no matter what r is, you're going to get this dy dx is equal to negative x over y. Okay, so you can kind of see a ghost of a circle, right? Or many circles, concentric circles in that slope field. And that's what helps, that's why slope fields are important, is that they can help you get a visual of what the solution is going to look like. So that's all I have for you. That was a quick lecture, right? So then there's just a few examples, a few discussion questions for you to look at. Like I said, I think drawing slope fields is pretty tedious, so I'm not going to have you draw a lot of those by hand. But you need to understand the concept and understand how they can be helpful. So I will see you in class.